Okay, so we're going to categorize all our numbers, and they're called the sets of numbers. Okay, so if we include every number there is in we call that the real. So you can see here we start off with the big circle, and that will include all the numbers. So then we're going to branch down into little categories, or we could call them subsets. So in real numbers, we have real. Now the next sort of two sets, we can either have irrational or rational. So the irrational ones are things like pi or the surds. Okay, so they're the irrational ones. If we look over at the rational numbers, they can be any number that can be written as a fraction, really. So we could say, a half. You can even say 0.14272 because we can write that as a fraction. And so rational ends up being any number that you can make. So it can be negative as well. So you can have -1/5. That's a rational. So then we branch these rational numbers down into even smaller groups. So then we say there's integers. Now integers are sometimes used as Z. They use a Z. So say they said, you might go, for example, they might say you have the set of X where X elements are Z. So that means all whole numbers are for Z, for the set of X. Okay, so that's whole numbers, and then in there we can have natural numbers. So they're pretty much okay, with their special notation, if we see the R plus, that means all real numbers in the positive, so above 0. So that will be X would be any number above 0. If you see the R negative, it means real numbers less than 0, so we'll see that. If you see R excluding 0, you're going to have in your set, you'll have all numbers except 0. If you see this Z plus, remember Z stands for integers or whole numbers, and if you got Z plus, it obviously whole positive numbers, so it'd be greater than 0 but positive, so we wouldn't have any decimals or half or fraction. So the next thing we're going to look at is the relation. If you have a relation, you get a set of ordered pairs. So what I mean, if you had y equals say 8x plus 2, you're going to get all these sets. Say if x is 1, you will get y is 10. When x is 2, you'll get y is 18, and so on. Okay, so there's the set. So you get these sets of ordered pairs, and what we're going to call the numbers that x takes on is called the domain, and the numbers that y take on is called the range. So the x is a domain value, and the y is a range value. So we'll be looking at talking about, when we talk about the domain, we're talking about what X can be, and when we're talking about range, what Y can be. And you'll see a few examples over the page. Now we do have this implied domain, which is just when, and it's the largest domain for which the rule has meaning. So it's mainly in practical applications. Say if we had, distance over time, because we don't have negative time, so we know time's always greater than 0. So that's when the domain is implied. So they're not going to say to you, there's no negative time. It's implied that you know that. And that's where you might not be told the domain. You have to remember that that's the case. Okay, if we go over the page when we do examples. So here in example 1, if you have a look, you can see the sets of numbers. So we've got 1, and the first dot is 1 and 2, second one's 2 and 3, third dot's 3 and 4, and we've got 4 and 5. So if we were writing out the domain for this relationship or this set of numbers, the domain will be all the Y values. So it's 1, 2, 3, and 4. And if we were writing out the range, it would be all the Y values. So 2, 3, 4, and 5. Okay, so when we've got a graph like in this example 2, we can see this graph would go on forever, and it's assumed that we know that because they're not putting a dot like over here. They've got just going on. So if you look, X could be when you talk about the set of X could be an element of the real field. So in meaning any number. So because it can go all the way into the negatives or all the way into the positives. So the domain we'll write is the real field. And the same with the Y. If we look, the Y is taking on any value if it just keeps going either way. So we'll say the range is the real field. Okay, down in this example 3, if we have a look, the X values is always somewhere between -1 and up to 1. So that implies when we write the domain, we can write it in with some set notation where we can use a square bracket. A square bracket means that number's included. And then if we see this, it means that it's -1 and it goes any number all the way up to +1 and including because of the square bracket. And if you look at the Y values here, the Y is taking on the same numbers. It could be anywhere between -1 and 1. So the range, if we were writing that, we can use this square bracket as again and go 1. Okay, if you look over on this example here, 4, you can see that X is anything greater or equal to 0. Now, why is it equal? Because that dot here is solid. So when we talk about the domain, we could write it in a couple of ways. We could say you could say it's the positive real field in union, including 0. That's one way to write it. Or you could write, we're going to put a square bracket and say 0, and we go every other number after that, which we can use infinity. When we use the infinity symbol, we put a curved bracket because we never reach infinity. So the curved bracket means that you don't include the last number that it's up to, but you can never reach infinity. So the range here, if you look at the largest number is Y is 2, and it's including 2, so it's going to go up there. Now because Y could be any number underneath that, we can write with a curved bracket, we can say negative infinity because it's all numbers before that. So so we could write the range like that. With this last one here, this example here, 5, we can see the domain. So what does the X values can be? It can be, see, -1. So -1's the smallest, and it can, and including, because this dot is solid. and all the way up to 2 and including. If I wrote the range of this one, it could be -3 is the smallest, all the way up to 3 and including. So if, for example, you have, like if we had, say, the same graph, but I put an open circle there, -1, 3, and I kept that one closed, we would say the domain, okay, because it's not including that one, we put a curled bracket, but it goes all the way up to 2 and it includes 2, so it's a square bracket. And the same with the range, it would be a curved bracket, 3, all the way up to a squared 3 with a squared bracket.